at CERN. I'm excited to be here. Just finished the tour. I feel that whatever I'm going to say, it's not as exciting as what I've seen. So sorry for that, but I'm super excited to be here. Thank you for coming. So in the next 45 minutes or so, I'm going to talk about a little bit machine learning. It's the hype right now. Everyone is talking about it. But I'm going to disappoint you a little bit. There is little to no LLM and Gen AI in this presentation, just for a change. We're talking about like standard machine learning and deep learning stuff. So if you are interested in LLMs and Gen AI, this is probably not the presentation you're looking for, but there are a couple of presentations, one today and two tomorrow from Dimitris and Lise, which they are going to cover it pretty well. So go make sure to attend those sessions. And the machine learning that we're going to talk about is going to be focusing primarily on Java and Java language. And the boring part, I'm Mohammed, I forgot to introduce myself. I work for an audio streaming company called Spotify, and I'm also a Google Developer Expert GDE for Google Cloud. Enough about the boring part. Moving on. I'm originally from Morocco, and I moved to Sweden. And don't ask me why, because I don't know. I'm lost in the darkness and cold right now. But it was a move like 3 years ago. And when you move to a new place, especially a new country, there's a lot of cultural changes, a lot of language changes that happen, and you need to adapt to that language, right? To know what it's happening, both from a political point of view, and if there is something happening, you don't want to be the one that is left behind and understand what's happening. So learning a language is good, especially if you're living in that place. And for learning a language, there is Benny Lewis, who has been crazy about learning languages. He speaks more than 20 languages. And he has an interesting techniques. What he does is basically, if he wants to learn Spanish, for example, he will go to a Spanish-speaking country, and he will just move from having no knowledge about the language, immersing himself, speaking whatever language or words he knows, and then slowly learning the language just by immersing himself and speaking with the locals. And that's to say there are two ways, actually, for learning the language. There is the traditional way, or the standard way, where you go to school or something, where there is a teacher, or you do it by yourself, where you learn the structure of the language, both from a grammatical perspective and everything that comes with it, and learn the structure of the language and how to make a proper sentence. But if you're just interested in speaking and interaction and understanding what's happening, you don't need much of that, right? You only need to understand what's happening behind you, or around you, and speak with the folks that you are interested in. And for that, that's when Benny techniques works pretty well. What he does is just immerse himself and start speaking the language. And he starts building what we call patterns in how the language is actually spoken and heard, and he starts building his knowledge and building those mental models in order to speak that language. He doesn't need the structure, he's focused more on the patterns. He doesn't really need to worry about the rules, but more of how he can basically build that pattern and mental models in order to speak that language. And programming as we know it is more of the first approach. Up until before machine learning, and up until recently, and what we're doing as developers right now, is to make the machine smart, we start by writing rules, and we call them programs. But basically, there are rules that we tell the machine to do in order to achieve something. For example, if you want to model a person that is walking, you take some parameters. In this case, is speed, right? And then you notice that speed and you make the rule that if the person is walking with less, let's say 4 as unit of measure, then the person is actually walking. And then your product manager came in and said, hey, we have this new requirement where we need to support running, a person that is running. Then what we do is basically look for presentations or patterns and make a new rule, which means that if the person is actually walking, then it should be under 4 by unit of measures. If it's running, if it's more than that, then it's actually is running. What happens is your product manager comes with a new requirement, which you need to model in whatever constraint you have, but you still rely on the speed unit of measure. And you add some other checks, like speed is limited, or running is limited to 12 by unit of measures, and then whatever else is actually biking. But the problem is when the unit of measure that we use completely changes. Like, for example, someone that is playing golf. Speed is not the unit of measure that we need to model a person that is playing golf, because like there is both running, walking, and standing involved. So relying on the speed alone in our rule engine is not enough. That we end up to do rewriting our whole application in order to add another unit of measures in order to model that. Machine learning is actually the opposite way. So what we do in traditional programming is we write down the rules to turn it into the appropriate output that we want. So we start by observing whatever we have, writing programs in terms of set of rules, and then end up with the output that we want. Machine learning and AI and all the fuzzword and the buzzwords that you hear about start by learning the data and the output. So you have a set of data that is there, which is your input, and then you feed it as well with the expected output. And it's all statistics, it's all math behind the scenes that you don't need to worry about. But it takes the input, it compares it to the output, and it builds the rules itself. So that's a big programming paradigm compared to what we have in traditional programming. And that is another way to make the machines, the computers, actually smart. Instead of feeding it with the rules, we let it actually figure out what the rules should be, and by feeding it with the data or the input data and the expected output, and they build in statistical models, a lot of statistics behind, and it tweaks the parameters in order to have a best guess into what it needs to be. So that's basically it. That's what machine learning is. It's a new programming model if you want to think about it from that perspective. I'm a developer, so I like to think about it as that way. That's basically a long sentence just to look fancy and understand what I'm saying, but it's actually just saying that we let the machine learn by giving it data, a lot of data basically, because machine learning needs a lot of data in order to tweak its parameters in the statistical model in order to detect the output. And the more data you have, the better. And something that we talk about a lot is in the pop science magazines and a lot of articles, they keep using AI and ML and sometimes deep learning interchangeably, but they are quite different. Artificial intelligence started to pop up and appear in the 50s. The 1950s, a lot of people in computer science started to get interested into how we can make machines intelligent. And we started building a lot of techniques, look a lot of patterns, and we figured that artificial intelligence alone excels in one particular scenario. Like for chess, for example, focusing on one thing, it does excel at that, but when we start to have fuzzy, complex problems, like, for example, natural language processing or image recognition, artificial intelligence wasn't really done for that. Then we started splitting artificial intelligence into multiple subfields to explore what the limits of what we can do. And that's where machine learning started to appear. Machine learning is a subfield and one of the most successful subfields of artificial intelligence, where we focus on using statistics and math in order to achieve, solve more of the complex problem that we have and make the computers more smart. Machine learning is very related to mathematics and statistics, similar to how medicine is related to chemistry. However, medicine deals with its own problems, same way as machine learning deals with its own problems compared to statistics. Machine learning is more focused on large data and complex data rather than applied mathematics and statistics and so on and so forth. So it's not only math, but a big part of it is actually math. And then we ended up with deep learning, which put an emphasis in successive layers. We'll come back to that in a minute. But in deep learning is actually how many layers we build in order to learn about or to build our model. And we have a graph afterwards. Where I go a little bit more in depth around that. And then the last part is what we start to hear about starting last year or probably the year before with ChatGPT, which is generative AI, which is a subfield also of deep learning. So up until deep learning, we were more focusing on prediction. Like we feed an input, and the model will try to come up with something that is close to the output as it can be. Generative AI focus on completely other thing, which is like generating actually new output, which is a new field, and it has its constraints and challenges as well. Back to deep learning, as I mentioned, the deep learning means actually how many layers you use to build your model. And typical deep learning algorithms use tens or even hundreds of layers in order to build a model that can be used actually in production. The two that we found generally are the input layer that feeds the data and the output layer, which is how many output. We call them labels, we call them answers, we call them responses. There are different naming for that, but we have the input layer, the data, and the output layer is actually the production. And then we have the hidden layers, which we train our algorithm or the model for to actually train our model. And that's where the deep learning comes from. It's actually the depth of your layers rather than how deep we go into the understanding, which is a general confusion that we have. Okay, moving on. How am I doing in terms of time? Okay, cool. And with the advancement of deep learning, we managed to achieve a lot of successful things regarding complex problem, like image classification, speech transcription, things like Alexa, Google Assistant, and everything that comes with natural language processing has been built using deep learning algorithms. Go playing, that was also achieved by that, and a lot of things that help to advance the internet as we know it now, which we're starting to see also tiny models that can be deployed in edge devices such as smartphone or even smaller than that enable to advance the machine learning and make it part of our daily life. Okay, I talked a lot about machine learning, AI, that was just an introduction, but then how to get started, right? And that's the thing that's bothered me because I'm a developer, I didn't come from a artificial intelligence background or machine learning background. Whenever I wanted to start, which kept me away from the field for a long time, is machine learning engineers were writing stuff for other machine learning engineers with little focus on developers and how to simplify things. So they keep focusing on mathematics concepts, a lot of the words that I have no idea what they mean, such as gradient descent, vectors, linear algebra. The moment I hear linear algebra, I'm uncertain, I shouldn't say that, but I'm a developer. I'm not as smart as you are, guys, but it's like I just run away. That's one of the things. And the other thing is actually Python. Python is a great language, have no problem whatsoever with Python, but I'm a Java developer. I use it on a daily basis. I would like an alternative to use it in building machine learning model or as integrated with my applications, because like that would speak more to me. And there are a little bit of few developers, around 10 million Java developers, that would like to have an option as well, rather than learning Python to do that. And I figured that when I started looking, actually, figured that it's not only my issue, but a lot of Java developers started to speak about it as well. And this blog from 2018 by Humphrey, who wrote a very good blog post. The link is in below, and we'll share the presentation afterward. A very good blog post on how actually to make Java, or the changes that has to be made to Java in order to support machine and deep learning models or algorithms. And a very good blog with very detailed techniques and things that we can add to Java in order to make it play nicely with that. So I was happy that was alone, but I had to wait a couple of years later in order to see that actually come to fruition. And the first attempt, and why Java again? You probably heard this before, and if I've been in the Java industry for long enough, you probably agree to some extent with some of the things. Java has helped us to get to the moon, right? It can be deployed for edge devices to huge servers. Its performance, it has a mature ecosystem with running mission-critical applications. The WARA principle, interoperability, works really well. Enterprise, it's the dominant language in the enterprise space that make it, if we can build, so the developers out there, enterprise space use Java a lot. So if we can make Java play nicely with machine learning, we can introduce more people to the Java or to the machine learning space. And the community, of course. Java has one of the coolest and amazing communities out there. I just spent the weekend with a couple of folks from the Java community. We were riding a lot of trains. In fact, I think we were on 16 trains in 48 hours, which was amazing, quite an achievement. I'll probably add it to my resume at some point. But it was cool, and we had a lot of discussions and insights, and a lot of fun in that, right? But the thing to say is Java has a strong community that can help you get up and running in pretty much anything that you face. And the rest of this presentation is going to be basically going through some of the libraries that I've either worked with or played with that uses Java in order to build machine learning, or at least use it in your language. So we're going to focus on 3 main libraries: Deep Learning for Java, Deep Java Library, and Tribuo from Oracle. And we will mention JSR 381, if I'm not mistaken, which is a standard approach or standard attempt to make Java and machine learning more standardized. Starting with JSR 381, or the VSRIC API. So the VSRIC API, or JSR 381, was an attempt to implement some of the recommendations that we mentioned in the blog, and some of the things that the Java community and machine learning folks were asking for in order to make the Java plays nicely in the machine learning world. And it's a GSR. We have a standard. We have an implementation. We have an interface and the reference implementation. The reference implementation come from DipNets, and DGL, which is from the Amazon one, has its own implementation as well. So it's a massive set of interfaces that enable that anyone can use. It's standardized the way we can interact with machine learning algorithms, especially for visual recognition and image recognition. Okay, enough slides, or I'll come back to that. But what I wanted to show, I have a small demo. Who watched that's small, right? Can you see it? I suppose you can. Who watched this what's it called? Silicon Valley show? Show of hands. Yeah, a few of you. So one of the scenes in Silicon Valley was a cool dude, geek, building an application back in the whatever that was to detect if the food is actually a hot dog or not a hot dog. And it does simply that. Detect if it's the food that it sees is a hot dog. If not, it shows that it's not a hot dog. Now, the investors weren't so amazed when they see that, but it does the job. So the VSRIC is actually less verbose and very compact as an attempt to use machine learning. And it implements convention over configuration, and it uses files to build, to train or build your neural networks. And what we do, so it's focused on the VisRec, as the name implies. It focused on image recognition. So basically, we will build in a neural network model. And the input would be an image, because I have a data set here with, OK, where is my data set? Should be in the resources data set. I have the train stuff. And you can see it has a lot of images of hot dog foods and some other stuff that is not hot dog, right? A lot of stuff in there. I just downloaded it from the internet. And then dictating or giving hints to my model about what the input is. So it's an image. The size is 128 for the width and the height. And this is what I like about VisRec, to be honest. Everything is file-based, and you can specify your neural network in files. The first thing is labels file. And labels are basically the output, the end layer, what you would expect. And what we have is, I should go to the resources. I am under it. The VisRec, yes. We have the labels. And we have two labels, which is a hot dog or not hot dog. Nothing fancy, just bear with me. We have the training file, which basically lists the training file, which the training assets, which is index, right? It should be this one. And it's simply, OK, it is simply a list of path where my image is and the label. So as my model is trained, it takes the image, check what it is, try to detect what it is, and then compare it to the output. That's why I said we feed it with the data and the output on the expected results. So that's the input, the data, the image, and the output is basically the label that we expect. And then it keeps training and training and training and try to figure it out and learn by itself. And then the network architecture. And the network architecture actually is defined in a file as well, which is this one, I suppose. And I'm not going into details for this one, but it's like a neural network model, a convolutional neural network, CNN, which is used in image classification. Basically, you have the layers, but instead of focusing on a pixel level, because in image processing, you want to improve for resources. Otherwise, you want to optimize for resources because we are dealing with images. And instead of focusing on pixel level, we build tiles. Because in a hot dog, if you think about it, whatever the angle you take of a hot dog, at some portion, if you split the image into tiles, you will find the same piece of hot dog somewhere. So we take those pieces and then we rank them, or what is it called? Parameter. Equation? Weight, yeah, that's the word, thank you. We give them a weight. And we compare that weight for whatever choice we find it. And we define our convolutional neural network. We have the max pooling, basically, and we're trying to build those layers. And then we will have our input somewhere. So that's basically defining our convolutional neural network. And then the max error, when to stop the training, when we error out, we don't want to, if the model during the training is erroring so much, we just like ignore that phase and then start training again, or during that epoch. And then we have how many epochs do we want, so the maximum number of iterations to train that model until it reaches a successful or a good learning rate. And then we specify the learning rate, and then where to export the model. And I have it already generated here. So we leave that, and I was able to train it on my M1 Mac, which is fine. But it's by no means a production model that you can deploy to your fancy application, but it's fine enough if you want to show a small demo. So I let it run for a couple of minutes, more than a couple of minutes. But when I came back, I generated the model, and I was able to try it out. So I like the fact that it's very much compact compared to other frameworks that we're going to mention in a minute. So I have my model. And then I want to integrate it in my Java application. And what it does is basically, I load my model. So from file, what's the network is a convolutional neural network. What's the input? It's an image classifier. And then I feed it with the data that I want, or not the data, but my image that I want to interfere, or the inference, to predict it if it's a hot dog or not hot dog. And then I get the results back, and then it's a demo thing, right? So the percentage should be if it's more than 50% probability that it's a hot dog, they're considered a hot dog, otherwise considered a not hot dog. I have two images, one of a hot dog and one of a not hot dog. So I did this before, and it worked. So supposing it should work again. The first one is a hot dog image. I should run it. It should take a few, hello? It should take a few seconds. This is a hot dog. So yeah, I was lucky enough to say it's a hot dog. So if I try to change it to something else, the image I have, it's actually pizza, right? Yeah, that was a pizza. If I try to run it again, you know, you're expecting it. It should say not a hot dog. It was tested before, so yeah, nothing fancy. But that was the Visreg API. Very compact, super easy to work with, especially if you're interested in image recognition. You don't have a fancy use case. It can help you a lot. There's a reference implementation with DeepNet, as I mentioned, but you can use other backend or other implementations, such as the DGL. Time is running fast. The second framework is Deep Learning 4G from Eclipse. Eclipse, or Deep Learning 4G gives you basically more power, but with more power comes more verbosity. It means it's very inspired by the Keras framework from the Python world, I think that's from Google, but it's open source as well. But it's a lot of the concepts in Keras framework are here, are implemented in the Deep Learning 4G framework. So it has multiple components. So it has the Deep Learning 4G, which is a library that focuses on implementing machine learning algorithms, neural networks, and a lot of things. And it does also import models from Keras and TensorFlow if you have already trained those models. The interesting part is the building blocks. The first one is ND for Java, which is a linear algebra library, and that's basically that does the heavy calculation to interact with all the mathematical stuff that is happening behind, and it's basically the brain that runs deep learning for Java. And it has the capability to switch between GPU or CPU, depending on what you have. And to optimize it, we have a bridge, which is Java CPP, and that's able, similar to what we do in Python, they follow the same approach, basically having switches or bridges that can optimize for speed and run directly into C++ data structures. And then we have libnd4g, which is like C++ power engine, and that's what interacts with the hardware. That's basically the architecture of Deep Learning 4G, and it's really powerful if you want to build your own machine learning algorithms or build your own neural network. It supports a lot of neural network architectures, convolutional neural networks, FFN, and a lot of them, the GANs as well. So they are predefined there, and you need to tweak them and build your layers in order to build your model or train your model. It can import and export models from other frameworks, such as PyTorch, TensorFlow, and Keras, which is really cool. If you have a use case and you don't want to, a simple use case, there are a lot of models from the community out there. If it's good for your need, you don't need to basically build it on your own. You can use it directly. Another strength is the ND4G library. I mentioned that. It's very efficient, battle-tested. It's really performant. They spend a lot of amount of time tweaking it, which is really good. And Deep Learning 4G, I forgot to mention that, was the first attempt to make Java play nicely with machine learning. It's been there since 2018, something like that. It's really good. And it can run with distributed training. I think it runs Spark behind-the-scenes with this, both Scala and Java, you can run it, but it supports that, and you can run it across multiple architecture, CPUs and GPUs as well. It has a lot of models.We, and the models.We is basically a set of pre-trained model that you can import directly and play with. or run them in production, and it has multiple APIs: Python, Scala, and Java. I know it's talk about Java, but yeah, worth mentioning that it supports other APIs. For the use cases, again, anything that you can do with machine learning and deep learning, image recognition, natural language processing, reinforcement learning. If you want to build a robot or a self-driving car or something, you can do that. Not sure if you want to do, if you have enough resources and you want to build a Tesla with your Java, but that could be a good project. I'm in if anyone is interested. Another thing I want to mention is Jupyter notebooks. One of the things that annoyed me for so much is I wasn't able to run Jupyter notebooks, or notebooks in general. This one is Google Colab, to use Java. It has improved a lot, and shout out to the folks at JBank that basically reduced a lot of the initial work in order to make Java works pretty nicely with few lines in Jupyter Notebooks. So basically, you install JBank, you specify your runtime, and then you can use any language you want. Oh, any language, any Java version you want. I'm using Java 21 because why not? And then I'm importing my dataset, the same one as we saw earlier, and it should be here. Don't know why. Okay. Yeah, it should be here. I downloaded it before coming to talk, so you can see it's basically all the data is here. And it's free, I believe, and you can run it to train your model. Downloading my dependencies here from Deep Learning 4G, and then importing all the files, and then running, again, my model. What you will notice is, I'm going to switch to IntelliJ because it looks nicer there, but yeah, it runs, I have an error, anyway. It runs on Google Colab and Jupyter Notebook, which is really good for being a nerd and also to share them with other folks. Okay, going back here, deep learning for Java, probably that one. And the one thing you will notice is more verbose, and that is because you have more power. So you specify your training data set, you specify your testing data set, you specify the number of labels that are the same. It's an image, you can tweak your images, you can transform them, flip them back, reduce their size. You can do a lot of that. It's supported as well. And then you define your neural network. And then here you can do, this is the part when you're going to invest and do a lot of work. And you can basically tweak each layer. They support different algorithms for the activation, the weights. You can define all the layers, and you can go crazy about it to tweak your model and build it. But it's more verbose, and that's for a reason, because they want you to have the power to decide on what you want. It's debatable on how you want it, but that's the way they decided to go with. Once you can build your network, and then you run your training. They have the UI server, which if you run, gives you how your algorithm is doing, and you can see the confidence or the probability going high of your model. So the UI server is the cool part, and then you can save it. I think saving the model is the last part here, and then you can test your model and check how performant it is in the evaluation part, which is really cool. So here I defined my own model from scratch. What we generally do is we don't start building from scratch. We take a baseline or generic a performance model that was already built, and we retrain it to our specific need. And that's what I did here, I suppose. So what I did is taking the ResNet model. Yeah, the ResNet is an image classification model that is available right there, battle tested, used by everyone, and then retrain it by another layer that is specified for hot dog or not hot dog thing. And that's what we generally do. We don't start building from scratch unless you have a specific use case. It starts from a model that is already available there, and you add your layers. And the good thing about deep learning, as I mentioned, you can build to specific layers and then add your layers as well, so you can tweak the model that you want to build. I think that's small, but sorry for that. That was that. OK. I'm running out of time. Go back to my slides. Deep learning for Java. Cool. Still have 10 minutes, if I'm not mistaken. But learning curve. Deep learning for G gives you a lot of power. However, you need to know what you are doing. Otherwise, you will shoot yourself in the foot. You won't know what's going on, basically, because some of the errors or you need sometimes to familiarize yourself with how it works. But it's really powerful, especially if you want to start playing with Java and machine learning. It's less high-level abstractions. I don't need all that verbosity. Sometimes it's better to use something that is more simple. Focus on deep learning and neural networks, and it has a slow release cycle, especially in the last couple of years. The momentum has went down a little bit. The other library, which is my favorite, it's Amazon, or the AWS Deep Java library. And they followed a different approach. They said, we're not going to build our own engine. There are enough engines out there in the world. We're going to build a layer that actually uses those engines, which is a really smart approach. So they have a couple of engines that rely on PyTorch, TensorFlow, really powerful. They have a huge community in there. And they add a layer on top, an interface, a Java interface that they have implementation of those depending on the engine that you pick, and that's basically it. And they use the power of those engines, TensorFlow, PyTorch, ONNX, to basically train your model, or basically deploy it and run your inference, which is really dope. Some of the key features of DGL. And the key feature is actually the multi-framework support. It supports a lot of framework that is widely used and adopted by the machine learning community, PyTorch, TensorFlow, and MNX, and others as well. It has a very simplified deployment model, and we'll show. They have even DGL server, which is kind of a server that you can run on your own, even using Docker, and that's the one I will show in a minute. The deployment model is really simple compared to others, like deep learning for Java, where you need to do it on your own. They have models.We, which is a predefined set of models that you can use instantly. They invest a lot in the models.We, and those models you can use pretty much instantly. Simplified deployment model. I just noticed that the simplified model deployment is redundant. The model server, which is the thing I want to show here. Going back here, this is a simple Java, or a simple application that they built. What it does is, I'm running it using Docker. Hello. Docker PS. You can see that it just download it from the Docker registry and run it. DGL server is called. And then you can add your model. And what I did previously, so you specify the URL where you can download it from, or you can upload it if you want. You specify a couple of metadata, and then you submit it. I already did that, and they mentioned the ResNet, which is an image classification algorithm. And you can see that I downloaded directly from somewhere. Here you see. And then it's already up and running. And what I can do is simply, it provides you with an endpoint, prediction / your algorithm. For me, it was traced ResNet. And I can upload an image. For example, yeah, we have a puppy here. It should work. Let's see what it will give us. That one, I never run it. So it will take some time, because it's generally something that you would do in a pipeline. When a user upload an image, you have a pipeline that is running to classify your image and give something. And yeah, it managed to define that it's a pug dog, with some confidence scores in there, which is really cool. If you want to just image classification issue, you don't need to build your own. There are enough algorithms, models out there that you can simply use and deploy, which is really cool for a lot of use cases that we deal with. Still have 5 minutes. Sorry for that. I should have managed my time better. The use cases, again, it's a deep learning, machine learning library, similar things that we mentioned in DGL, or deep learning for Java, image recognition, natural language processing, blah, 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 fraud detection, if you're working in finance, credit card stuff, security, you can do video analysis and face recognition and so on and so forth. A lot of the use cases that apply generally with machine learning. Model compatibility, you might run into issues. Some versions of PyTorch compared to others cannot be, or aren't supported, so you might run into compatibility. That's one of the things that you probably would run run into, but it's gone better throughout the years, so I'm using it a lot better. I'm noticing that a lot of improvement right now, and it's debatable, the last point, like limited deep learning framework support. I believe the frameworks that they support are the one generally used and widely used, but someone would not agree with me, and I thought that just to mention it there. Oracle Tribuo. It's from Oracle, and it powers a lot of the enterprise features that are available in Oracle Cloud, and it's rather than focusing on deep learning, they just focused on traditional machine learning issues such as linear regressions, is VT, I think it's called, and something like that. So they focus more on traditional machine learning algorithm and not specifically deep learning, which is fair, because like not everyone would need deep learning stuff in to build their models. A lot of the companies, especially in the enterprise world, would need some simplified machine learning that can integrate ideally with their existing constraints and their existing challenges. And that's what Tribuo actually brings to the table. So they invested in kind of an ecosystem. So they support multiple data sources. They can plug in with your database, CSV file, whatever. So that's a good thing that I find. You can tweak it to build and train your data set or your model. And they have different kind of decorators in order to take whatever input you give, whatever data source, and turn it into a Tribuo compatible format that can be trained for them. And then running the model, nothing fancy here. They will take care of that, and then they build your model to run your inference and run your prediction model. Again, the key feature is they don't focus on deep learning stuff. They more focus on machine learning, simple ones, and especially from an enterprise point of view. And they excel in that, and they have a lot of algorithms that can support enterprise scenarios. They invested a lot of data processing in how to get your data and shape it in something that can be easily used in the enterprise world. So that's something they can. It's a good thing, I believe, for in Oracle Tribuo. They have evaluation metrics, making it easy for everyone basically to understand if what their models is doing, check their models and check if the training is going well or not. A hyperparameter tuning, when you get your technical word, but when you get your data, so there's a parameter when you train your model, and the hyperparameter, well, like how you tweak your data before making it available. They work well, and they have multiple plugins and libraries that help you, again, make your data available and integrate it in the data pipeline. And it can scale to run it in multiple nodes and do distributed training. Use cases, again, simplified machine learning stuff, spam detections, sentiment analysis, and stuff like that, and the traditional machine learning that are not focused on the deep learning stuff. But some of the missing features, I would say, it's not focused on the deep learning. You might need it. Then, if you need it, then Tribuo is not the right thing for you. It has a heavily focus on enterprise stuff. It has interoperability with non-Java ecosystem. If you end up having something for that, it has a smaller community. I think it was built in 2021, 2022, something like that, and that justifies that it has a small community compared to both DGL and Deep Learning 4G, but they are there if you want to give them a try, especially for the enterprise forks like there. When to use each, I find DGL the easiest one to use. It has a strong models.We, simplified approach, and the powerful engines behind like TensorFlow and PyTorch, so you want to be on your own. Those ones are really rich and really up to date. Deep Learning 4G, if you want to stay within the Java world, but have more control over what you want to build. So that's something that if you want Deep Learning 4G and Java, and you want to have full control, then Deep Learning 4G is something that you want to have. And then Tribuo, if you're in an enterprise context, when you want to focus on everything that is not deep learning, but more traditional machine learning stuff. This is a nice slide to show that having a full pipeline from getting the data until deploying it can be complex. Up until recently, we didn't have the training part and data part that include Java, but that luckily changed right now. So we can do from training up into deployment full Java, which is something I find really cool in the Java ecosystem in 2024. And I'm right on time. Thank you very much. And there are some of the resources.